Now we are going to see a number in complex. It says, show that the modulus of 1 minus I the whole power 6 over 1 plus I is equaling to 4 root 2. So this number is dealing with the modulus specifically of complex numbers. So the hint we are going to use, you know that x plus iy, if you want to get the modulus of x plus iy, this is the real part, this is the imaginary part. What do? You get the square root, you square the real plus the square of the imaginary part. We also know some properties of modulus, that modulus of z1 over z2 is the same as separate modulus of z1 over separate modulus of z2. And then another important property in modulus says if we have modulus of z power n, it's the same as modulus of z, then that power n. So those are the properties we are going to apply here. So now we can start by getting the modulus. So now if I want to get the modulus of the whole of this, now I want to get the modulus. I want to make sure that the modulus is this. Now I have this case. Now I'm going to apply that property. So if I have that, this is the same as separate modulus of 1 minus I power 6 the whole over modulus of 1 plus I. So I've applied this property here. Then I'm going to apply this property here specifically on this. So this will be the same as now modulus of 1 minus I the whole power 6 over 1 plus I. So what do we need? Now I need to get a modulus of this. Remember, when you have a modulus of a real part and imaginary, we square that, then we get it and the square root. So now this will be the square root of, now I'm dealing with the first one, the upper one. So let's get 1, the real squared, plus the imaginary. The coefficient of I is -1, which is the imaginary. But the whole is having power 6. The whole over. Now here, this is modulus of this. You get the square root. The real is 1 squared plus the imaginary. So the coefficient of I is now 1 squared. So this will be, this is 1 plus 1, which will be root 2. So we have root 2, the whole power 6 over, this will be root 2. And you see now here, we are going to use properties of indices, that if we have a power m over a power n, this is the same as a power m minus n. So it's this one, the whole of it is power 1. So now this would be the same as, by the way, you know that 2 is the same as, okay, root 2, the whole power 6, then minus 1 in that order. So now you know that root 2 is the same as when you take this up using this property. So 2, root 2, remember that our root is the same as a half. So I have 2 power a half, the whole thing, power 5. And you see, if I try to simplify that with ease, I have 2.5. So I have this now. My modulus of 1 minus I the whole power 6 over 1 plus I is equaling to, now this is the same as 2 power 2.5, which I can write as the same as 2 power 2. You know, when we have indices, this is the same as 2 power 2. Remember how I can write that 2.5 from here. I have 5 divided by 2, which is 2.5. So this is the same as 2 in brackets 2 plus 0.5, which is the same as 2 power 2 times 2 power a half. This 0.5. This is going to be 4. Then 2 power half, the same as root 2, and the proof is done, just like that. So anyway, this is just for explanation, but so that you can do this in less than 4 steps. So that's how you had to show that in simple terms. That's it, members. I wish you well. Don't forget the oral script of the topic of complex numbers is full, you go to playlists, you'll see complex numbers, you'll see them from the starting point. That's it, but please don't forget to subscribe to the channel. See you there.